I feel like it's more fun when it's challenging.
Hi, this is Ava with Tutor Hub 101, and today we're going to be going over how to find the inverse of a 3x3 matrix using augmented matrices. Today you will learn how to check if a matrix is invertible, finding the inverse, and verifying the answer by multiplication. The example that we'll be looking at is that guy right there. Okay, so let's get started. So first, to check if it's invertible. A matrix is invertible if it has a determinant and the determinant is not equal to 0. So that's what we have to check here. So how do we find the determinant of this matrix? Well, the first step is to copy the first two columns right next to the matrix like this. And then what we're going to do is we're going to do 3 diagonals. This is the first one, and we multiply all the numbers. So this one is 2 times 2 times 1, which is 4. Then we do the next one, 1 times 5 times 0, which is 0, so plus 0. And the next one is 4 times 3 times negative 1, which is plus a negative 12. Then we go the other way. So 4 times 2 times 0, that is going to be 0, so we subtract 0. Next one, 2 times 5 times negative 1, which is minus a negative 10. And the last one is 1 times 3 times 1, so minus 3. So all the ones that are yellow get subtracted, and all the ones that are green are going to get added. And so our final answer is going to be negative 1. And since negative 1 is not equal to 0, that means that our matrix is indeed invertible. Okay, so let's move on. So now we're actually at the step where we're finding the inverse. I'm going to start out with our matrix, and the first thing we're going to do is augment this matrix, which means it's going to look something like this. This is what an augmented matrices looks like. It has this line right here, and on the left side it's going to have the original matrix, and on the right side it's going to have the identity matrix, which is basically ones down the diagonal and then zeros everywhere else. So when trying to invert the matrix, what we want to do is we want to make the left side look like the identity matrix. So whatever's on the right side will end up being the inverse. Let's go over some of the rules that we can apply here. Basically, you can apply any of the linear operations. So if you think about solving a system of equations, any of the rules that we can apply there are the same things we can do here. For example, let's just take a look at, let's say I have x equals 5. I can multiply both sides by a number. For example, if I multiplied both sides by 3, I would end up with 3x equals 15. And so we can see that x is still equal to 15. So multiplying an entire line by an integer is good. We can go ahead and do that. Then there is adding. We can also add the same thing to both sides, and that will also preserve the integrity of the equation. Let's say I wanted to add 3 to both sides. Then I'm going to have x plus 3 equals 5 plus 3. And so obviously here we can also see that the answer will still be x equals 5. And so once again, it is preserving the equation. So these are all of the things that we can do when we're trying to find the inverse of a matrix. Okay, I'm going to tell you guys what my steps are as I'm going through them. Basically, as I said, we can multiply any line with anything, and we can add 2 lines together. So the first thing we're going to do is row 2 minus row 1. We're doing this because I realized that each of these numbers in the second row are 1 greater than the number above it, which means if I subtract, I will end up with 1s along the second row here, and I feel like that will probably be useful. Okay, so the way that I have this written is that I write down the rule that we're going to be applying, and I write it right next to the row where I want to insert the answers. Let's go ahead and try that. So when you do this, the only thing that should change is the second row, because we're only applying this rule to the second row. Okay, so let's get started. So what we're doing is row 2 minus row 1. The number in row 2 minus the number in row 1. So the first one is going to be 3 minus 2, which gives us a 1. Then 2 minus 1, which is 1. 5 minus 4. 0 minus 1 on the other side, and that gives us negative 1. Then 1 minus 0, which is still 1. 0 minus 0 is 0. Okay, so since my objective is to get a 1 in this position right here, I think it would be a good idea to subtract row 2 from row 1 now, because not only will that give me a 1 in this position, but it will also give me a 0 in this position. And that is very much like the first two numbers in the identity matrix. So we're going to go ahead and do that. My rule is going to be row 1 minus row 2, and I will be inserting it into the first row, which means the second two rows will remain the same. Okay, so first thing is going to be the 2 minus 1, and that's 1. 1 minus 1, 0. 4 minus 1, 3. 1 minus a negative 1, that's 2. 0 minus 1 is negative 1, and 0 minus 0, that's just 0. Okay, so we're getting a little bit closer. We just take this one step at a time and we get closer to our answer. Okay, so now, looking at this, it looks like it might be easy to get a 0 in this position, which is also part of the identity matrix, also what we're looking for. And we can just do that, in this case, maybe by subtracting row 2 minus row 1. And we're going to insert that into row 2. So that's the empty row here. So row 2 minus row 1 means we're going to do 1 minus 1 and get a 0, 1 minus 0, and it keeps the 1 right there. 1 minus 3 is a negative 2. Negative 1 minus 2 is a negative 3. 1 minus a negative 1, that's going to be a 2, and 0 minus 0 is 0. So looking at what we have so far, we have 1, 0, 0 in the first column, which is perfect because that's exactly what the identity matrix has as well. And it looks like what we could do here is maybe try and get a 0 in that position. So the rule is row 2 plus row 3, and we're changing the last row, so that's blank. Okay, so let's go ahead and add them. We're going to do 0 plus 0, which is 0, negative 1 plus 1, which is 0, negative 1 minus 2, which gives us negative 1, 0 minus a negative 3, and that's negative 3, 0 plus 2, which is 2, and 1 plus 0, which is 1. Okay, so now as we can see, we're getting even closer because now the first two columns are identical to the first two columns of the identity matrix. Okay, so now what we're going to try and do is get a 0 in this position, and we can do that by multiplying the third row by a negative 2 and then adding it to the second row. So the rule is going to be row 2 minus row 3, and we're going to insert that into the second row. We're going to do 0 times 2 times 0, which is 0. Then 1 plus 2 times 0, which is 1. Then negative 2 minus 2 times negative 1, which gives us the 0 that we wanted. And then negative 3 minus 2 times negative 3, which gives us a positive 3. 2 minus 2 times negative 2 gives us a negative 2. And 0 minus 2 times 1 gives us a negative 2 as well. Okay, it looks like we're getting very close. Now maybe we can try and change this guy to a 0. And we're going to do that by multiplying the third row by 3 and adding it to the first row, because that would change this guy to a negative 3, and when we add it to 3, we'll end up with a 0. And we're going to insert the answers into the first row. And let's go ahead and do this computation. So 1 plus 3 times 0 is going to give us the 1 still. Then 0 plus 3 times 0 is going to be 0. And then 3 plus 3 times negative 1 is going to give us the 0, which we wanted. Then 2 plus 3 times negative 3, that's going to be a negative 7. Negative 1 plus 3 times 2 is going to give us a 5. And then 0 plus 3 times 1 is going to give us 3. Okay, so now if we take a look, we are actually almost at our answer, because this looks very much like the identity matrix. The only thing is this negative 1 right here. So we want to change that to a positive 1, and we're going to do that by multiplying the third row with a negative 1. So once again, we have the next matrix with only the third ones blank, and let's go ahead and just change all the signs of the third row. So +1, +3, -2, and -1. And so this leaves us with our final answer, and here is the inverted matrix. Okay, next we're going to check the answer. We know that an identity means that if you have a number, let's say 5, and you multiply that with the identity, we should get the answer 1. And so in this case, the identity of 5 is 1/5, because when we multiply that, the 5's will cancel and give us the answer of 1. And so that's what we're going to do in order to prove that our inverse is actually correct. We're going to take our original matrix and multiply it to the inverse matrix we just found, and confirm that the answer is in fact the identity matrix. So I'm going to show you guys a quick way to multiply matrices. Let's go ahead and try it out. The first thing we're going to do is we're going to make a quick table like this, and in the bottom left corner we insert our original matrix, and the matrix that we want to multiply this with actually gets inserted in the top right, but we have to transpose this matrix. So what happens is the first row actually goes first in the bottom, then we're going to have the next row, and then the third row. So before we get started, keep in mind that we want our answer to look like this, and if that's the case, then that means that we did in fact get the correct inverse matrix. So the way that you do this, you're going to do 2 times -7, which is -14, and then 1 times 3, which is +3, and 4 times 3, which is 12, plus 12. So all of this equals a 1. And then for the next number, we're going to have 2 times 5, which is 10, 1 times -2, which is -2, 4 times -2, which is -8, and this is going to be a 0. Then the next number, we're going to do 2 times 3, which is 6, 1 times -2, so -2, and 4 times -1, which is -4. And this does, in fact, give us the 0. Then for the next row, we're going to do 3 times -7, which is -21, 2 times 3, plus 6, 5 times 3, plus 15, and this gives us a 0. Then the next number, 3 times 5, which is 15, 2 times -2, -4, 5 times -2, -10, and that gives us 15 minus 14, which is 1. Then 3 times 3, 9, 2 times -2, -4, 5 times -5, which is -5, and this ends up being 9 minus 9, which is 0. And for the last row, we're going to do 0 times -7, which is 0, -1 times 3, so -3, 1 times 3, plus 3, and that's 0. Then 0 times 5, which is 0, -1 times -2, so plus 2, 1 times -2, -2, and that gives us a 0. And the last part here is going to be 0 times 3, which is 0, -1 times -2, so plus 2, and 1 times -1, which is -1, and that does in fact give us 1. So we can see that our answer when we multiply these is in fact the identity matrix, and so we know that our inverse is correct. If you thought this was a helpful tutorial, please leave a like at the bottom. Let me know in the comment section what topic my next tutorial should be about. And don't forget to subscribe.